Okay, I wish you all a good semester. I hope it will be productive, it will be fun, it will be healthy. This course, as the name implies, it's about game theory. It's about non-cooperative game theory. Before we go into the details, let me give you some information from the syllabus, but I also need a copy. May I have a copy, please? Thank you. Now, a note about spare hours. So we'll meet on lectures just like today, Monday, 10:40, 11:40, Thursday, 8:40, 9:40. Now, the 8:40 hour is a spare hour, but I'm kind of a slow teacher. So in order to cover as much material as we can, I would like to use some of the spare hours. You will not be charged anything extra for that. And unfortunately, I will not be paid anything extra for that. So for the first couple of weeks, I will use the spare hour. I know that you all have other classes. So towards, after 4 or 5 weeks, I know that your midterms, other exams will start. So I'll stop using the spare hour. But for the first couple of weeks, I will use the spare hour. I will always let you know a week before, except for this week, okay? Since the class has started, I would like to use the spare hour this week also, because you see, ad drop ends, I think this Friday or next Monday, I forgot now. I had it written somewhere. So before ad drop ends, I want you to get an idea about this course as much as you can, so that you can make a good decision whether to take or drop this course and take another one, okay? So this week, I will also use the spare hour. The only thing, if this is too early, we can start a little later. We'll talk about that during the break, okay? So this week, we will use the spare hour, and next week, also, we will use the spare hour. I will always let you know a week before whether we will use the spare hour next week, okay? So this Thursday, we'll meet earlier. We'll talk over the break. If you want to start early, if you think this is too early, you want to have some cup of coffee or breakfast before you come, we can start a little later, but I would like to use some part of the 8:40 class. Office hours, I haven't set up office hours yet. I'm waiting for a few things to be announced. There's a workshop series that we have in the department. I would like the hours of that to be finalized. So as soon as those are finalized, I will announce the office hours. But office hours, the thing about office hours is that unless something very important comes up, unless I'm ill, somebody in my family, or somebody who needs my help is ill or needs my help, or there's a very important meeting that I have to attend, I will be in my office during office hours, and you will have priority, okay? So even if I'm doing something else, if you come, I will just say, give me a minute, let me just finish this email. You will have priority. At other times, you should also feel free to stop by my office for questions or discussions, okay? So as you should see me as soon as you don't understand something, you get stuck with something, you have problems, you should see me as soon as possible. You should not wait for the office hours. But at other hours, I keep the right to say, sorry, I'm busy, come again half an hour later. Sorry, today I'm busy, come again tomorrow, okay? I will not do that during office hours. Office hours, you have priority. At other hours, you should feel free to stop by, but other things may have priority, depending on how busy I am, how urgent things are, okay? So don't wait. If you have problems, don't wait. See me as soon as possible. Before the course description, a word about the book. The book that is closest to what I would like to do in this course is a book by Martin Osborne, An Introduction to Game Theory. We placed an order for the book, but unfortunately, it was out of print. So the bookstore could not bring the book. There are 2 copies in the library, and I placed the 2 copies on reserve. So you can borrow it from reserve I think, for several hours, or I don't know, the reserve conditions, okay? So you can use that, but because we don't have the book, I will, from time to time, send you lecture notes, okay? But in the library, there are quite a number of books on game theory. Some of them don't have the mathematical rigor that we like. Some of them are for graduate level, is too much. But the important thing about having a book is to have a book which has problems in it. I will give the definitions. I will send you the definitions. To learn the stuff, you have to solve many, many, many problems, okay? Well, the nice thing about game theory, it's, you can find many problems from life, so you can make up a lot of problems. I will be sending you problems. But also, you can look into the books, even if it doesn't have any math, even if the level of math is too high. You can borrow the book and just look at the problem sections, okay? So unfortunately, this is a nice book. It has several examples. The level of mathematics is not exactly at the level that we will require, but it's close. But unfortunately, it was out of print. Regarding that, Martin Osborne and Ariel Rubinstein has another, so Osborne and Rubinstein has another book, A Course in Game Theory. Osborne and Rubinstein. Okay. Well, unfortunately, this is also a nice book, but it's at graduate level. But the thing is, Rubinstein is well, both of them are nice people, but Rubinstein has placed the PDFs of this book on his webpage. So if you go to Google, write Rubinstein, game theory, that will, I'll send you the link. I'll email you the link where the book is. So it's available on his webpage. You can download it. The level of mathematics is more than what we want, but it has the definitions and it has some problems in it. It's a nice book, but the level of mathematics is a bit more advanced than what we will be doing here. Okay? Any questions? Any questions? None? The outline again, I'll skip that. So we'll have 2 midterms, each of them of weight 30%, and a final 35%. And I will give a homework almost every week. And we may or may not, I don't know, depending on how things go. We might have in-class unannounced quizzes now and then, okay? So all of them will make up 5%, okay? The weight of that is very low. The main thing by doing the homework is solving problems and getting ready to the midterms. My observations up to now is that students who work on the homework seriously do well on the midterms. Students who don't submit their homework, again, on average, mostly, don't do that well in the exams, okay? So I strongly recommend that you think about the homeworks, work on the homeworks. I think group work, discussing with your friends, is a very, very good way of learning things. So form small groups of 2, 3 people and discuss about the questions with each other. But again, by discuss, I don't mean that there should be one person answering all the questions and the rest copying, okay? Solve them independently, get together, discuss about your answers, discuss about the things that you got stuck with. You can come and discuss about the homework questions and any other question with me, okay? That's perfectly okay. But the thing that I ask for you to is, when it's time to write down the homework, write it on your own. If you work with your friends, you have some notes, throw them away, write down what you have in your mind, okay? So please, please, please don't cheat, okay? Work together. I strongly encourage that. That's a very efficient way of learning things. Discussing with each other, it's very good. But when you're writing it, please write on your own. Okay? Any questions? Any questions? So regarding FC grades, I don't give FC grades. Everybody is eligible to take the final, but that doesn't mean that everybody will pass. Unfortunately, every year a group of students fail. But there's no reason to fail if you study regularly. See me when you're stuck. I see no reason for everybody to get good grades. Okay? Any questions? Any questions? None? Don't be shy of the camera. You should feel comfortable. Well, if you don't have any questions, this might be a recurring theme. When you don't ask questions, I do ask questions. So since you don't have any questions, I'll give you a quiz. This is quiz number 0. By the way, this is a question that I get. I give this similar quizzes in several of my classes. That's a question that is frequently asked. Two of the questions is about the negation of a statement. Negation of a statement P, which we usually denote with this symbol, or some books, or some people denote it like this, some people denote it like this, is a statement such that whenever the statement P is true, its negation is false. Whenever the statement is false, its negation is true. Okay? So the negation of a statement is a statement which is false if and only if the statement is true. Okay, so what is game theory about? What is this course about? Well, as I said, it's going to be about non-cooperative games. So whenever I say game, in this course I will mean a non-cooperative game. So what is a game? Well, game is a situation which involves more than one, I will say, agent, player. And what do I mean by an agent? An agent could be an individual like you and me. It could be a firm. It could be an organization. It could be a country. So whenever I say an agent, a player, I mean one of those. Again, it could be a firm. I could be referring to a firm. I could be referring to an individual. I could be referring to a country, any organization. Okay? So, but not any group of agents are involved in a game. So what else do we require for a game? Well, we require interaction among these agents by means of actions. So people take an action. There's a group of agents who take actions. Again, we're a group of individuals here. We're taking an action. I'm talking. You're listening. You're going to be asking questions, answering questions. So we're going to be interacting by means of actions. But that's not enough for us to call this situation a game. We need a few extra things. Well, each individual is aware that their welfare, their happiness, depends on not only on their action, but on the action of the other individuals that he or she is interacting with. So all such situations we will call a game, which is a very large class of situations. Okay? So some examples are in the paper that I gave. I will display them on the projector on the screen. What will we do? Well, what we will do is we're going to construct mathematical models of such situations, situations where a group of individuals interact by means of actions, and their welfare depends not only on their own actions, but the actions of the other individuals that they're interacting with. We're going to model these situations. And why are we modeling? Well, we're going to model these situations in order to predict what they would do, or in order to prescribe, recommend what they should do. So we're going to analyze such situations. And beside this, we will probably not have time to do it in this course, but I will try to do at least one example. Another thing that we use these models is to design games. So to design auctions which satisfy certain conditions, to design tax laws, okay, to attain certain conditions, to design voting rules, okay? So we will take such situations, use mathematical models in order to predict what the agents would do, in order to prescribe the agents what they should do, and also in order to design institutions, laws, rules, so-called games, which, when the agents interact according to these laws, according to these rules, certain desirable results come out. Okay, that's the whole purpose. Okay, so, but to start with, we have to be able to model these situations. So that's what we're going to do. So what do we mean by a model, a mathematical model? Well, a mathematical model is a mathematical description of the common and essential elements in these situations. Okay? So what we will do is we'll start with looking at some game situations, okay, which is in the sheets, but also put on the display. So the first situation is a famous game called the prisoner's dilemma game. Okay? So we have two individuals. So again, the first condition is met. We have more than one individual. They're arrested allegedly for engaging in a serious crime. Okay? The district attorney takes them, puts them into 2 cells, and he gives them the option of confessing their crime. Okay? So what happens is, if each one, privately, the district attorney goes and asks him whether he confesses the crime. So if the individual that he asked is the only one to confess, so one of them confesses, the other one doesn't, the one will be rewarded, will get a lighter sentence of 1 year, while the other one, well, since this individual confessed, now we know that they have committed the crime. Moreover, he lied to the law. Okay? So he will go to jail for 10 years. Okay? Well, if both of them confess, then they'll both get 5 years. If none of them confess, well, they will be charged for a lesser crime. They were carrying an unauthorized concealed weapon. Okay? So then they will get a lighter sentence, which is how many years? 2 years. Okay? So this is exactly a game situation. There are two individuals. They interact by means of actions. Their action is whether to confess or not the crime. Okay? And so let's call them suspect 1, suspect 2. The welfare of the suspect, that is the number of years that is going to be jailed, doesn't only depend on his action, it depends on the action of the other agent. So this is exactly a game situation. This is one of the most famous games in game theory. Okay? So we'd like to be able to model this and then study this, analyze this, so that we can predict what these suspects would do or prescribe to them what they should do. Okay? So another game situation is an auction. This one is a bit of a different auction. It's called a second price sealed bid auction. Let me start with this sealed bid. Well, we have a group of agents. Okay? Rather than calling them Ali, Veli, Ayşe, Fatma, we'll just index them. The first, the second, the third, the fourth, the fifth. Okay? So they're interested in buying an indivisible object. So we cannot cut this object into pieces and give part of it to 1, part of it to 2, part of it to 3. Only one person can get it. So let's say that's a famous painting. Okay? So each of them values this object at a different, let's say, price, money. Let's assume everything is measured monetarily. Okay? So I own this object. I would like to sell it. The problem is I have a bunch of individuals who's interested in buying it. The problem is I don't know how much each of these individuals values this object. If I had known that, life would be easy. then I would just pick the person who values the object the most, and I would say the rest can leave, and I will just bargain with that person. I don't know how much each and every one of you value the object, hence I don't know who valued the most. That's when auctions become a valuable tool, okay, to elicit information about how much these individuals value the object, okay? So I decided to conduct an auction to sell my important painting, okay? So the method auction, there are many methods of auctioning objects. The one that we're going to use is called second price sealed bid. Sealed bid because, well, we will play this game, and when we're playing this game, I will ask you to write your bid on a piece of paper and seal it. That is, don't show it to anybody, okay? So nobody will see how much you bid. That is, when agent 1 bids, the other agent doesn't know what he bid. When agent 2 bids, the other agents will not know what he bid, he or she bid, okay? So that's where the sealed bid comes in. The second price, well, I'll collect the bids. I'll give the painting, the object, to the highest bidder. If there's only one, I will give it to the highest bidder. If there's more than one, we call there's a tie. We need a tie-breaking rule. Usually the tie-breaking rule used is you put the names in a bag and draw one of them at random. So you give everybody an equal chance. Well, I don't want to introduce randomness at this stage. So what I'll do is I'll sort them according to their names, give the object whose name appears on the top of the list, okay? And how much will this individual have to pay? He will have to pay the highest bid made by the other individuals. That's why it's called the second price. So I don't ask him to pay the price he bid. I will ask the price bid by the agents other than him, by the rest of the agents, okay? That's why it's called second bid. It looks like a crazy method. But this is a game situation. More than one individual is involved. They interact by means of actions. Their actions is writing a number on a piece of paper, okay? And their welfare, that is, who wins the auction and how much he pays, not only depends on what he wrote, the action he took, but it also depends on the actions of the other agents. So this is a game situation, okay? Okay? Any questions? Okay, so there are certain more games. I will not go into each of them. I will just pass them fast. It's on the paper. We'll play this game too. Okay, so it will show up. So another standard model is Cournot's model of oligopoly. Some of you maybe did this a little bit in 101. I think you definitely did it in 203 204 macroeconomic theory 2. We're going to do it maybe a little bit more detailed, but we'll still. So again, there's a bunch of firms. So players, agents now become firms. In the first two examples, it was individuals. Now players or agents are firms. Each of them decides on how much to produce. So they interact by means of the actions. Their decision on how much to produce determines the total quantity in the market, okay? Well, these firms want to sell everything they produce, so they sell at the market clearing price. So there's a demand for their good. Using that demand, we determine the market clearing price. They sell at that price, okay? And they prefer a high profit to a low profit. Again, this is a game situation. There is more than one firm. They interact by means of their actions. Their actions is deciding on how much to produce. And their welfare, their profit, that's what they care about, does not only depend on what they produce, it depends on what each firm in the market produces. So exactly a game situation. So we go on like that. Well, let me put that so it shows up on the video too. Entry deterrence, we'll do this one too. Voting, okay? So let me give a few more examples so that we can start modeling. Chess is a game, okay? So white, then the rule says white moves first, then black, then white, then black. And then there's certain actions that the players can take. White cannot move any piece to any place. there are certain movements that he can make. And it tells that under this condition, white moves, under this condition, black moves, and under this condition, there's a draw, okay? And each player prefers winning to losing. So chess is a game that falls into our category too. So we don't only do serious things like auctions, voting. Chess is also a game for us. Poker, okay? There's a rule, I think, I'm not sure about this. The papers are dealt clockwise. Some people are saying yes, so we know who's the players. We have to be careful about them in this course. So then, you look at your cards and you tell how many cards you want to change. So you say, I want to change 3 cards. So the other players sees how many cards you're changing, but they don't see the cards that you get, okay? And then, you win, you bid a certain amount of money, and we're assuming that each player prefers winning more money to less money, okay? So that's also a game. So what we like to do is, and there are many, many, many situations. So there's many things that falls into the category of a game. So what we like to do is, we'd like to find out what is common, essential, and takes different values from one situation, again, values in quotation, from one situation to another, okay? And we'd like to first determine those and represent them mathematically so that we can tool the powerful tools of mathematics in order to make predictions and prescriptions, okay? So ask yourself, in all these situations, and the ones that we just described, like chess, like poker, and many, many other situations that you can think of in life, what is common and essential? Again, when you're doing this, so what we want to do as a mathematical model, it's usually a good idea to start describing them verbally and then translating them into the language of mathematics, okay? So what is common and essential in all these situations? Yes, sir.
There are outputs for all players.
So there what?
There are outputs.
There are outputs for
All players.
all players. Okay. So what do you mean by outputs?
What is considered positive in a game?
What is considered positive in a game? What is considered good for the agents in a game? Okay. What else? You had something? It's always dependent on someone else's actions. Anybody else? Any other takers? Yes, sir? There are always different rules for the game. Okay. Anybody else?
Seems you're always interested in winning.
You're always interested in winning. Okay. Anybody else? Anybody else? Yes, ma'am. There's always a set of players, okay? Now, actually, that should be the point of starting. So, for example, one of your friends said there's an output. What was your comment? What was your?
There are outputs for all players.
There are outputs for all players. So in order to talk about all players in our model, we need players, okay? So somebody said agents prefer winning. So for somebody to prefer winning, you first have to have somebody. You have to have individuals, players, agents in your model. So we have to start with saying that there is let me try to write better. I'll use agents again. When I say agents, sometimes, so two things. Sometimes I will call them agents, sometimes I will call them players. A note about gender. Sometimes I will call he, sometimes I will call she. I think most of the time I will call he because it consists of 2 words. The other one consists of 3 words. Being an economist, I'll economize on words and writing. So there's nothing about gender. That's the way I will use it. So there's a set of agents. So in all these situations, there is a set of agents. So that's what is common and essential. If there was only one agent, it wouldn't be interesting for us. It's still an interesting problem in different domains, but not in our domain. Okay? What is common in all of them, in the prisoner's dilemma, there was 2 agents. In chess, there's 2 agents. In poker, I don't know what the minimum number is, but of course, for it to be interesting, I guess it has to be at least 3 or 4. Okay? In auctions, it depends. Sometimes the government does auctions. Sometimes there are 4 firms. Sometimes there are 5. So it depends. In painting auctions, there could be hundreds of people attending the auction. But the thing is, there is a set of agents, and it changes from problem to problem. Okay? So that is common and essential in all those problems. Okay, so what else? What else?
There's a range of actions these agents can take.
There's a range of actions that they can take, right? In the first prisoner's dilemma, the agent had 2 choices, confess or not. Okay? In the second prize seal bid auction game, they could write any number that they could fit onto the paper, right? In chess, well, white can move, not any piece, but there are certain rules on which piece and where they can move it. Okay? So in poker, first they have to decide on how many cards they want to change, and then they have to decide on how much to bid. Okay? But you know, coming to those things, it's so in some, for example, in chess and poker, there was an order in which they took actions. It couldn't start with black, or any agent cannot say, I'm going to move now. They have to wait for their turn. Okay? So before taking their actions, there's a rule which says when they can take an action. Okay? So let's add that to their list. Action. And now, given that we told, so it says white moves first, then black, then white, then black. The players decide on how many cards to change counterclockwise. Well, in the prisoner's dilemma, it doesn't really matter. The district attorney could go to suspect 1 first, then to suspect 2. Okay, first visit Ali, then Veli, or first Veli, then Ali. It doesn't matter here. Okay, but once we determine this, then we come to what your friend suggested. What actions can they take? Yeah. Okay. What actions can each agent take? Okay. So, next. Well, it's time for a break. So let's take a 10-minute break. After the break, we'll finish. Wow, my handwriting is really bad. I have to do better. So after the break, we'll continue with this list. By the way, I will send you some notes which has these things. So you don't have to write them, but think about them. Okay? So let's take a break.